Welcome to the mathematics and a new video to the MIT Integration B 2020. This integral here is from the qualifying round, 1 over tangent to the power square root of 2020 plus 1, and the bounds are from 0 up to pi over 2. And yeah, if you see that, why is this pi over 2 there? Why are the boundaries like that? And also the power root 2020. Is there a special reason for that? Of course, this is because of the year, but the exponent is not really important in that case. And yeah, what kind of method do we use to solve this? If you think about the tangent and the relations between the cotangent, we have seen this trick a couple of times in the last videos, and we will use the property of integrals. If we have from 0 to a f of x dx, then it's the same to integrate f of a minus x in the same boundaries. Yeah, and we will see why this helps. This is because of this pi over 2, and yeah, then we can use some symmetry properties and some shifting properties from the tangent, obviously, and then see what we get. Yeah, and why this works, this is the same like with the e function. Yeah, because the tangent has the property that there exists a co-function, so cotangent. This is 1 over tangent, and by the shifting it comes back to the tangent. Okay, that's why this trick works. And with the e function it's the same. If you have e to the minus x, it becomes 1 over e to the x, and by this plus 1 we will see that this plus 1 is also important in that case. And yeah, whenever you see something like functions with special behavior plus 1, this is a nice way to go. At least you should try it, and we will see what we get. Okay, so we rewrite this integral from 0 to pi over 2 of 1 over tangent to the power square root 2020 pi over 2 minus x plus 1. And yeah, like I said, the value of the integral, it doesn't change. So if I call this integral I, then this is also I. And if we add them up, these two, we get 2i equals, we use the linearity of the integral, and we use the shifting property. So here we have 1 over tangent square root 2020 plus 1 plus 1 over tangent pi over 2 minus x is exactly the cotangent of root 2020 to the power 2020 x plus 1. And now what I would like to do to add them up, we need the same denominators. And because of the relation between tangent and cotangent, it makes sense to extend the second fraction with tangent root 2020 plus 1 root 2020 x plus 1. And now what we get here, we have pardon, without the plus 1, I'm sorry, without the plus 1. So we extend with the tangent to the power root 2020, And now what we get is cotangent times tangent is 1. And 1 times tangent, so we get the same denominator here. Alright? So what we get, integral from 0 to pi over 2. We have the same denominator right now, tangent to the power root 20 plus 1. And in the denominator, we have tangent plus 1. Tangent to the power root 20 plus 1. And now, yeah, the whole fraction is 1. So we are left with integral 0 to pi over 2, 1 dx. Yeah, and this integral is easy to evaluate. This is pi over 2. If we take a look at the right, on the extreme left hand side, 2i, and the extreme right hand side, pi over 2. So we divide by 2 and we get I is pi over 4, and this is exactly what we are looking for. So we are done at this moment. So the final value, pi over 4. And yeah, that's all for this video. I hope you liked it. See you next time.